Okay, so morning everyone. Today we'll start a new course that is Azure DevOps. Okay, so before start any topic or anything, today we'll discuss more about what exactly meant by DevOps, what a DevOps engineer actually do in his day-to-day life. Okay, we'll focus on that. So, what kind of tools available? What is the basic architecture of DevOps and everything? And then we'll jump into other topics. Okay, for example. If you take any website, if you take any website, for example, it could be www.flipkart.com or anything, any website you can consider. It has some web page, means it has some data. So that data must coming from one server. So if you consider this as a server, and inside that they might host an application called Flipkart, and whatever the code or data related to this application might be they kept on the same server. Okay, this is data related to the Flipkart website. Okay, so whenever the request comes, it has to fetch the data from the local server where exactly it hosted. It could be data as well as code, both. Both they'll host under the same server itself. Okay, so now, for example, if something needs to change or something needs to be added to the code, what we need to do? We need to edit this code. Okay, we need to edit this code. Basically, that code needs to be edited by the developers. So developers having the responsibility to create the code, to update the code, or to make any changes to the code. They are the solo responsible persons. In this scenario, developers are sitting at somewhere. Okay, developers are sitting at somewhere. Dev paper. Okay, they're sitting at somewhere. Now, if they want to modify the code, what they need to do? They need to log into the server and they need to modify the code here. Okay, but if they directly jump into the server and they directly modify the code, if something goes wrong, what will happen? The website gets affected. Okay, and it's bit difficult to track the change whatever he made. Okay, there must be a mechanism which will keep track of what developer is making the change, what is the code previously available, and what is the code he changed, and after that, what is the code. Okay, there might be some kind of tracking needs to be enabled. Okay, and that is first point. The traditional system doesn't have tracking enabled. This is one drawback. And second one, so if you are making any changes, the first step you need to do is you need to take the backup of the existing code. So yes, I'll take the backup, but where I'll keep that backup, I will store the backup same on the server only, or else I'll keep it on my local system. So if you take the backup like this, you will naming conventions will be different. You can keep it as this today's date, or somebody copies that backup as with release date or release number or any name you can give it, right? So other people won't know. So you are not the only one person who is doing the changes. There might be many developers, there might be many engineers who is working on the server. So it'd be difficult to track the backup, what exactly the backup taken for this release, because releases are going very frequently. So it'd be difficult to track which backup is related to the which release. Okay, so that is nothing but versioning. Okay, it's a bit difficult to track the code as well as the version, how many times it was taken, what is the latest version, what is the latest backup available. It's a bit difficult to track. That is one thing. And second thing is, for example, if it is a single server, then it's absolutely fine. You can keep your backup here, you can keep your code here. It will take that application, the code and backup from here itself. But what if you have multiple servers? Whatever the mechanism you are following, The same mechanism will you follow for all the servers? So let's say what if you have 100 servers, it's a bit difficult to go to each and every server and to make the changes on every server, to take the backup on every server. It's a bit difficult, right? So that is the reason we need a mechanism which we need to centralize the code, centralize the backups, or centralize the versioning, and it could be available for any server to pull it. Okay, that's how the version control system came into the picture. It's called version control system, or we can call it as code base or code management or anything. So this version control system, basically what it will do, it has a separate centralized location where it will allow to maintain the tracking, maintain the versioning, and maintain everything related to the code. So the simple thing is you need to place your code in the version control system, and you need to establish a mechanism to pull that code directly to the server. And from the local, the developers have access to the version control system, and they can come and they can pull the code to their system, and they can make update their changes to the this version control system. There is no need to place the code into the server. There is no need of the developer log into the servers. Okay, they can simply put their code to the version control system, and from there the code will be pulled to the server. Okay, this is the traditional architecture of the environments previously. Okay, now if we consider the same into the DevOps practices, you have your version control system here, and you have your server here. Okay, now the developer sits at this location. In this scenario, so what I said that the code you need to keep it under the version control system. So in this scenario, if you place your code in the version control system, the developers goes and access the code into the version control system, and this code, once they made change and they push their code to the version control system, and we need to have a mechanism to place that code into the respective server. So that mechanism, we used to call it as CICD. Okay, so this is called continuous integration and continuous delivery or deployment. We'll talk about each and everything in detail later. Okay, I'm just explaining the overall architecture. So we as a DevOps engineer as a responsible to prepare the architecture like this. So we need to create a version control system and make the developers able to pull and push the code. So they need to pull code to their local system, and they make their changes, and they used to push the code to the version control system. And from there, we need to establish a pipeline. It's called CI/CD pipeline to deploy or to place that code to the respective location. It could be server, it could be anything. Okay, that is our responsibility. Okay, and coming to the bit more, for example, if it is a single server, it's fine. It could be on-premises server, it could be cloud server, or it could be anything. Okay, in previous days, we have servers in place, like on-premises servers we place, but now these servers are replaced with cloud. The servers are replaced with cloud. The cloud, in the sense, it could be any cloud. It could be Azure or AWS or GCP. Like in the market at the moment, coming to the version control systems, we have many tools available. That is GitHub, and second one is Azure Repos, and we have Bitbucket, we have Code Cloud, we have Tortoise Suite, we have GitLab. There are many tools available in the market which offering a functionality of version control system. And Coming to the CI/CD, yes, for the CI/CD also there are many tools available in the market. One is Azure Pipelines and Jenkins and Travis, Bamboo, Argo, Octopus, like many. GitLab again, GitOps. There are many tools available in the market which will provide a functionality of CI and CD. And coming to the cloud, we have many tools available in the market, many providers, I can say. One is Azure, and second one is AWS, Amazon Web Services, and third one is GCP, and we have K5, and we have IBM Cloud, and we have Alibaba. There are many cloud providers available in the market. Okay, and now along with this, coming to the server part or coming to the cloud part. So in previous, we have a single type, multi-tier architectures. We have application servers, we have web servers, we have database servers. So we have a multi-tier architectures. Now, at the moment, they are into the microservices architecture. So in addition to these responsibilities, as a DevOps engineer, we need to take care of containerization tools and orchestration tools. That is containerization and orchestration. So what is meant by this containerization? What is meant by this orchestration? That we will discuss. But these are into this cloud only. These are also a kind of destination where you used to push your code, where you used to establish a CI/CD to deploy the things directly to the container or orchestration tool. These container and orchestration tools available in the market are Docker or Docker or many tools available in the market. Whereas content orchestration, we have Kubernetes, we have OpenShift. So there are many tools available in the market which will provide a functionality of containerization and orchestration tools. That also lies within the cloud only. Okay, it is also a kind of destination where you used to push your code. Okay, so in addition to that, for example, I have my code here and I placed my code into the version control system. Basically, every code contains a combination of files, or code is nothing but a collection of files. Code is nothing but a collection of files. So from the dev system to the version control system, they used to push this collection of files. But from the version control system, they cannot directly deploy that collection of files to the server or to the container or to the Kubernetes. Okay. So what they need to do, they need to pack it. They need to pack it and they need to transport it, because this version control system is placed at somewhere and this cloud is placed at somewhere, and you need to transport your code from this version control system to this particular place. So it's a bit difficult to transport them as a collection of files. Instead, we used to pack them. We used to pack them and we used to transport them. So to pack that code, we will use a concept of CI. So with this CI pipeline, the collection of files can be converted into a package. This package we used to call it as artifact. Okay, this package we used to call it as artifact. So this artifact or this package will be generated with the help of CI, with the help of CI pipeline. So the same pipeline, they split it into the two parts. The same pipeline, they split it into the two parts. That is CI and second one is CD. So what CD will do, CI will generate one artifact which will club or which will package the collection of files, and CD will transport that package to the destination and unpack it and deploy it. So that is the responsibility of the CD. That is transport to destination and unpack. That is the responsibility of CD. Now, again, for this also, for this CI and for this CD, as I told you, whatever the available competitors or available tools in the market, similarly, whatever the package you generated, if you want to store that package or that artifact along with your code, like collection of files, you are anyway storing in your version control system, and you are establishing a CI to pack them as an artifact or as a package. And if you want to publish that artifact directly to the cloud or directly to the deploy, it's absolutely fine. But before publishing it or before deploying it, I need to keep it somewhere. I need to store this artifact also. Yes, there are available tools in the market. Those are Artifactory, JFrog, Nexus, okay, and Azure Artifact. So these are the tools available in the market which will store the artifacts. Okay, so with the CI pipeline, the collection of files can be converted into a package or artifact and store it into the this respective locations. And the CD pipeline will take the artifact from this respective location and it will try to deploy into the respective place wherever you suggested or wherever you defined. So this is the typical flow. And along with these tools, you need to handle some of the tools for testing purpose because whatever the code developer developed and he pushed it to the version control system and he is trying to package and whatever package you are trying to deploy, before deploying it or before placing it, you need to test it. Okay, you need to test it and you need to verify everything is working as expected or not. If it passes the test, then only you need to deploy it. For that testing also, we need to implement as a part of CI/CD only. You can implement in CI or you can implement in CD. It's up to you. Okay, wherever before I want to package, I want to test it. Yes, you can test it. Or before I want to push it, or before I want to deploy it, I want to test it. You can test it. The same testing part you can implement in CI side or you can implement in CD side. Again, for that testing, we have many tools available in the market. Those are SonarQube, and we have Azure Test Plans, and again you have Selenium or whatever the test cases you can write, or you have GitHub Copilot you have in the market right now. So there are many tools available in the market which will offer a functionality of testing. Apache JMeter. There are many tools available in the market for the testing purpose. Okay, so these are the things as a DevOps engineer you need to manage. In addition to that, in addition to that, so whatever I said that you have a code and that code the developers they used to push their code and with the help of CI/CD the developers need to the place code into the respective server. But if you want to put your code, you need a server, right? It must be created inside that cloud. You need to create that server. You need to create that container. You need to create that Kubernetes. You need to create that environment here. For that environment creation also, we have many tools available in the market. That is infrastructure as a code, or we can call it as infrastructure creation. For that infrastructure creation, we have many tools available in the code. That those are Terraform, and if it is Azure, you have ARM templates, and we have a bicep templates. And if you want, you can create using PowerShell also. There are many tools in the market. Or if it is AWS, you have a cloud native templates. Okay, so there are many tools available in the market which will use to create the infrastructure. The first and foremost step is you need to select a cloud or you need to select a server, and there with the help of infrastructure as a code, you need to create your environment first, and then the developer work start. He is to push his code to the respective place, and from there, as a DevOps engineer, with the help of these practices, we need to establish a CI/CD pipeline. We need to create a pipeline based on the tools available, and we need to push that artifact to the respective places. And then, with the help of the CD pipeline, we need to place that code to the infrastructure, whatever you created, right? In that infrastructure, you need to place your code. So this is the typical architecture of a DevOps, and these are the roles and responsibilities you need to perform in your day-to-day life. Again, the name comes to the DevOps very particularly to the specific provider. I can say it is Azure DevOps. That means you must have the environment or you must have the cloud selected as Azure. Then we used to call it as Azure DevOps because you are performing the DevOps operations into the Azure environment. That's why we used to call it as Azure DevOps. If you select the environment as AWS, then that we used to call it as AWS DevOps. So they might prefer some of the tools here. For Azure, they might prefer some of the tools. For GCP, they will prefer some of the tools. Altogether, they will pick the respective tools and they used to deploy into the respect to the cloud provider. Based on the cloud provider, we used to call the DevOps as the respective DevOps. For example, if it is Azure, Azure DevOps as I mentioned. So for Azure DevOps, what we will basically learn from the version control system, we used to learn Azure Repos. And coming to the CI/CD, we used to learn Azure Pipeline. And coming to the artifacts, we used to learn Azure Artifact. And coming to the testing part, we used to learn SonarQube as well as Azure Test Plans. And coming to the cloud part, we used to learn about Azure. And coming to the infrastructure as a code, we used to learn ARM templates, Bicep, PowerShell, and Terraform. And coming to the Docker and orchestration tools, we used to learn Docker and we used to learn Kubernetes. So these are the things typically we will cover in Azure DevOps. So any environment you can say they will follow this only. In some environments, they might use Jenkins in spite of Azure pipelines, or they might use GitHub, or they might use Bitbucket, or they might use Code::Cloud. And similarly for artifacts, some people will use JFrog, some people will use Nexus, and some testing purpose also. Some people use SonarQube, some people use GitHub Copilot, anything. Same for the cloud as well, and same for infrastructure as a code as well. There are many tools available in infrastructure as a code, like Tofu also recently come. There are many tools available in the market. So there are hundreds of the tools available in the market. But as a general practice or a generalized environment, we will follow or we will learn these much tools. But altogether, functionality wise, everything purpose is same. Every tool purpose is same. Whatever the purpose that Azure pipelines fulfills, the same purpose will be fulfilled by the Jenkins. Same for the Travis. But the UI might be different, the syntax might be different, but altogether the purpose is same.